In this video we're going to look at how we can calculate the mass of a single ion in chemistry in kilograms. So if you think about that, this is going to be a very, very tiny mass. So we're going to be looking at calculating the mass of an ion in kilograms. In chemistry, we use the periodic table to give us values, or we might use the isotopic mass if we were given it. But that would be the mass of 1 mole. Okay, so that would be the mass of 1 whole mole. Remember that 1 mole is an awful lot of particles. 1 mole is 6.022 times 10 to the 23. So if we're talking about the masses that we see in the periodic table or written next to symbols of elements, we're talking about the mass of a lot of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 21, run out of space, 22, 23. So this many, and so the mass of 1 is going to be minuscule if 24, for example, here is the mass of that many. Alright, so what does this mean to us, and how can we calculate the mass of 1 and have it in kilograms, because these masses in the periodic table are going to be in grams. So this number here at the top, 24, means that 24 grams of a sample of magnesium 24 contains that many ions. So how many kilograms, or how do you turn grams into kilograms? So 24 grams would be 24 times 10 to the minus 3. I need to divide by 1,000 or times 10 to the minus 3 to get my number into kilograms. So how much would 1 weigh? So all of these together weigh this much. Therefore the mass for our time of flight calculations, m in kilograms, which is our SI unit of mass, is going to be 24 times 10 to the minus 3 divided by, shared out between all of the ones that we've got. So get your calculator out and see if you can type that in using the standard form button at the bottom. See what you get. There you go, that's what I'm getting. 3.985 times 10 to the minus 26 kilograms. So a very, very tiny mass. If you wrote that out, remember that you'd be seeing 25 noughts before you saw that first number. So 0.00000, 25 noughts before you saw that first number. So in general, how do we work out the mass of an ion? The mass of an ion in kilograms is equal to the relative isotopic mass, so that's the number given in the top right hand corner by the element, the relative isotopic mass, and that's space, times 10 to the minus 3, that's the conversion into kilograms, divided by Avogadro's number, that tells us the mass of 1. So this is to convert to kilograms. And this bottom number is to find it for 1 mole. So what I'd like you to do now is pause the video and see if you can do that calculation 3 times to work out the mass in kilogram of the following ions. So on that first one, the relative isotopic mass was 40 from the top. Turn it into kilograms and divide by Avogadro's, and you should get this. And then I've got my second one. Notice that because this mass is over 100, we're now in times 10 to the minus 25. But if you're not getting minus 25 or minus 26 for these masses, you're probably going wrong somewhere with your calculation. So do just double check, is it a very small mass? And then for the final one, I've got 3.155 times 10 to the minus 26. Now I've given all of these answers to 4 significant figures because Avogadro's constant was given to 4 significant figures. The relative isotopic mass was obviously only to 2 because it is a number of protons plus neutrons, and therefore it will never have any more. So I wasn't using that as my indicator. I've gone with the level of detail they've given me in the Avogadro constant, so I've gone for 4 significant figures. In the next video we will look at how you then can use this mass to calculate kinetic energy.